Hello guys, how are you? Hope you people are doing well and your preparation is going well. We we came up with new topic stack and queue. So we will discuss that. So it will enhance your knowledge in subject data structure. First we will look at what is a stack and what is queue individually. And then we will discuss the differences between the stack and queue. So let's proceed. What is a stack? A stack is a linear data structure. In case of array, random access is possible. That is, any element of an array can be accessed at any time, whereas in the stack, the sequential access is only possible. Okay, so that is important thing. So it differentiate stack from array. It is a sequential. It is a container that follows the insertion and deletion rule. The principle is LIFO, last in, first out, in which the insertion and deletion take place from one side, known as top. In a stack, we can insert element of a similar data type. That is, different data type element cannot be inserted in the same stack. Means for different data types, we need different of stacks. The two operations are performed in LIFO, push and pop operation. So let's see what are those operations. This is a stack working on a principle of LIFO. So if I am adding one data element, then operation is called push. I am pushing the data in the element. And if I am removing the data elements from the top, is called pop operation. So this is a adding of element and this is a removal of element. Removal of element. Okay. And the pointer is called top. Pointer is called top. The following are the operations that can be performed on a stack. First operation is push operation. So it have an argument. It have an argument or value that is pushing inside the stack. It is an operation in which elements are inserted at the top of the stack. Push function, we need to pass an element which we want to insert in a stack. And pop operation, it will return the value of the last element. It is an operation in which elements are deleted from the top of the stack. In a pop function, we do not have to pass any argument. So another function is peek or top. This function returns the value of the topmost element variable in the stack. Like pop, it returns the value of topmost element. It returns the value of topmost element, but does not remove that element from the stack. So it's like we are inquiring which element is at the top. Okay. And it is also a query is empty. If the stack is empty, then the function will return value true, or else it will return a false value. So these are true and false only. Is full also. If the stack is full, then operation will return true value, otherwise it will return false value. So basically only these are the actual operations, push and pop. It is adding value and it is deleting value, and these are only inquiring functions. So from top we are knowing that what is the value at the top and is empty. We are checking the stack is empty or not, and similarly a full is full. We are checking that stack is full or it have a still have a space to add the items. Okay. In a stack, top is a pointer. Top is a pointer which is used to keep track of the last inserted element. To implement the stack, we would know the size of the stack. We need to allocate the memory to get the size of the stack. There are two ways to implement stack: static and dynamic. So static can be done with the help of arrays and dynamic with the help of linked list. Okay, so these are the two type of implementation of the stack. Hope you got it. Okay, we will go further. Next is queue. A queue is a linear data structure. It is order list that follows FIFO principle, first in, first out. A queue is a structure that follows some restriction on insertion and deletion. In the case of queue, insertion is performed from one end and other end, and that end is known as rear end. Deletion is performed from another end and that end is called front end. So at front end we are removing and at rear end we are adding. So see, like this is a queue. So we are adding from here and deleting from here. So it is called front end and it is called rear end. So we are adding at rear end and we are removing from front end. In queue, the technical words are in queue and dequeue respectively. So it is for insertion and it is for deletion. So like we show here, we are adding element, we are calling it in queue, and we are deleting this element, we are saying it dequeue. Okay, so it is a front end from where we are deleting, and it is a rear end. It is a rear end. We are removing. We are adding the values. Whereas in case of a stack, technical words of it for insertion and deletion are push and pop, what we have already seen. Its structure contains two pointers, front pointer and rear pointer, where the front pointer is pointer that points the element that was first added. Okay, it was added firstly, so it is a front pointer in a queue, and rear pointer that points insert the last element, this element. Okay, because we are adding and it is moving like that. So this one what we added in first and this one what we added in last. Okay, so don't confuse, it's like a train. Okay, front is front and rear is rear. So we are adding the what we say, coaches at the end of the uh, uh, engine. Okay, and we are adding like that. So front is called where first coach is there. Okay, and rear is where last coach is there. It's like that, you can understand like that. Okay, next is similarity between stack and queue. There are only two similarities between stack and queue. First, both are linear data structure, which means both are storing the values sequentially and accessed and can be accessed in a single run. Okay, and flexible in size. Both stack and queue are flexible in size, which means they can grow and shrink according to the requirement at runtime. So that is important. Okay, guys. Next, the difference, we will see the difference, but before difference we will see something. So this pointer is called top. Okay, it it tracks the last value, and we are adding push operation means we are adding element, pop operation we are deleting the element. Okay, so in the stack it is important insertion and deletion happens at the same. Okay, and while in the queue insertion and deletion happens on different end. Okay, that is important. And so if we see here, we are adding, we are enqueuing, and this is rear portion. It is a front portion, we are dequeuing means we are deleting the element. and it is first in first out. So if we are moving like that, this element would have come first and this was last. Okay, so whichever come first will go out first. That's why it is called first in first out. And if we see, this is a like vertical, you see it is a vertical structure, and if we see this one, this is a horizontal structure. Okay, so these are the difference and we will see more difference. So we'll go to the one table. So basic comparison, if we talk about the principle, stack has a LIFO, last in first out, which implies that element which is inserted last would be the first one to be deleted. And Q, if we talk about Q follow principle of FIFO, first in first out, which implies that element which is added first would be the first element to be removed from the list. Okay, if we talk about a structure, it is only one end from which both the operation insertion and deletion take place, and that end is known as top. While in case of Q, it has two ends, front end and rear end. The front end is used for deletion, while the rear end is used for insertion. Number of pointers used, it contains only one pointer known as top. Top pointer holds the address of the last inserted or topmost element of the stack. And in case of Q, it contains two pointers, front and rear pointer. The pointer points the front pointer holds the address of the first element, whereas the rear pointer holds the address of the last element in Q. Already seen it in figure. If we talk about operation perform, it performs two operations, push and pop. Push operation insert the element and pop operation removes the element from the list. Similarly, Q perform also two operations, in Q and DQ. In Q means insertion and DQ means deletion. Okay, next, examination of empty condition, and it is important. Sometimes they ask question on this also. Okay, what are the empty conditions? So if top equal to -1, which means the stack is empty. If front equal to -1, or front equal to rear +1, which means the Q is empty. Same condition for full condition, we will check. If top equal to max -1, then stack is full. If rear equal to max -1, the condition stack is full. So if we are observing max -1, top equal to max -1 and rear equal to max -1, both have a similar condition for full stack. Okay, and similar condition for empty stack front. Okay, variants, it does not have any types, and it is only called stack only, but it has a three types: priority queue, circular queue and double-ended queue. Okay, so we have already seen questions on priority queue, circular queue and double-ended queue in our objective series. Implementation, if we talk about implementation, it has a simpler implementation, while in case of queue, it is comparatively complex implementation than the stack. If we are comparing from stack, then it is only complex. If we talk about visualization, stack is visualized as a vertical collection, while queue has visualized as a horizontal collection. So we already talked about this. So hope you have understood what is a stack, what is queue, what are the similarities between them, and what are the differences between them. Hope when question will come on stack and queue, you will be able to perform and you will do a correct answer. So if you are not understanding any concept, please write us in comment, so we will come with some more. Okay, thank you very much.